So in this video, we're going to have a quick-ish review of functions. And so this video is really intended for like pre-calc students and above. So I assume you've heard this before, but I'm just going to remind you of kind of everything about this at a faster pace. So functions usually are represented with this f of x notation, and something important to remember about them is that functions are interchangeable with the variable y very often. So for instance, if you saw something like f of x equals 3x plus 8, you could rewrite this as y equals 3x plus 8, so you can just literally flip them out. And so just one other thing I want to note, we read this as f of x. So very important that you just, use the vocabulary with functions in the right way. Okay, so what is a function anyways? So in math, a function refers to a specific relationship between the inputs or domain and outputs of a math expression. And these are called also relations. I'll explain what that is more in a few minutes. Now, what's specific about this is that for each distinct input for a function, there is exactly one value of the output. So I think that definition is a little heavy sometimes. Like I feel like that's something that people read and then they're like, okay, whatever. So I like to visualize this because I think having a visual explanation, I always feel like this works much better. Okay, so check this out. I have here, it doesn't even matter what this is, by the way. It could be numbers, it could be people, whatever. What we have here are two sets of, I just made dots so that you don't get hung up on this being like a math thing. It doesn't have to be numbers. But okay, so the first set is the domain and the second set is the range. And I just want you to appreciate like what this relationship is. So notice in this first set of relationships, each thing in the domain goes to exactly one thing in the range. So when that happens, that sort of mapping happens, that's a function. Now, this type of relationship is also a function. So notice, these two things in the domain, they're going to the same thing in the range. That's okay. That's not a problem. This is still technically considered a function. So what is not a function is really captured in this little diagram here. So notice I have one thing in the domain going to two separate things. So this part right here, maybe I'll circle it for you. This part right here, this is where the problem lies. You can't have one thing going to two separate things, okay? That would make it not a function. So that's really what we're looking for. If one thing in the domain goes to two different things in the range, that's a problem. Now, another handy feature of functions is that they make it extremely clear what you want to input into an expression. I have some examples where we'll look at this in a few minutes, but that's just another reason why we kind of like functions. They make it very clear what you want to do. Okay, so I want to go through a little bit of vocabulary with you guys just to refresh your memory. So vocabulary that comes up with functions, domain. So this is considered to be the set of all independent variables of a relation. So I always think of the domain as either inputs or x values, and I want to point out just in this definition, notice that I said of a relation, not of a function. So just keep that in mind. I'll explain what a relation is in a moment. But the big thing I just think about intuitively with what a domain is, I always think of it as what are the x values allowed to be. That's what I think of a domain as. Now, the range is the set of dependent variables of a relation. You could also think of it as like outputs or y values. What can the y values be? That's usually the way that I think of it. And once again, I said that this is of a relation, not of a function. So why do I keep saying of a relation? So a relation is any set of ordered pairs. So any set of ordered pairs makes a relation. So I bring this up because some relations are functions, but not all functions are relations. So if we go back to this little picture I had here a few minutes ago, all of these types of relationships are considered relations. This right here is a relation, it's just not a function. So everything is really considered, everything that has like an input and an output is considered to be a relation. It's just very specific when we actually are talking about what a function is. So just to be clear, domain and range can always be found even if we're not working specifically with a function. So you can almost always find your domain and range. So what I want to do now is I want to practice with domain and range a little bit just to kind of remind you of what that is. So I have here a set of points, inputs and outputs really. So just to kind of remind us. So the first point is always going to be our input. This is just like something that we know in the notation. And then the second point is going to be our output. So when you have a set of points like this, it's actually very easy to determine what the domain and range are. So I'm going to be nice and visual with this. So my domain are these first parts of the points. So 2, 5, and -3. And then the range is that second part of the point. So 3, -1, and 7. And I want you just to appreciate that we can also map kind of how these points are related. I put in the input of 2, I get the output of 3. So this mapping, is this considered to be a function? Yes, this is a function. So we're good to go here. Cool. So now let's look at another set of points. So I'm going to do the same thing. I'm just going to list out what the domain versus the range is. So my domain is -1, -8, and then -1 again. So there's no reason for me to repeat it. If it's in the domain, you only have to state it once. Now the range is 5, 8, and 6. And if I go ahead and I try to create a mapping, 1 goes to 5. Oops, sorry, this should have been 3. -8 goes to 3, and then -1 also goes to 6. And so we can see here, right, this is a problem, so this would be not a function. So when you have a set of points like this, it's nice and straightforward. You might have to draw a little map, but it's pretty clear when you've got a function. Now, another way to determine if you have a function is by using the vertical line test. So on a graph, if any vertical line intersects the relation more than once, then the relation is not a function. So what does that mean? Well, what I'm going to do is I'm going to show you a set of examples where we're going to find the domain and range, and then we're also going to determine if the graphs are functions. Okay, so here's kind of that classic graph here. So what I'm going to do is I'm going to draw a vertical line, and so you can see, boom, boom. This vertical line intersects the graph twice, therefore it's not a function. The second that happens, it's not a function. However, it is still a relation, so we can totally still find the domain and range. So let's find the domain and range, and we're going to use interval notation for this. So if you're not familiar with interval notation, I'll drop a link to my interval notation video in the description. Okay, so you really want to like focus your eyes here, because I feel like I used to get really confused with this, so I understand why this is hard. And I've found that domain and range is really a trick of the eyes. Okay, so with what we're looking at here, and let's assume, by the way, that this graph continues in both directions for forever. So what we're going to notice here is just on the x-axis, so where do I have x values? So over here, there are no x values, right? So this part isn't, there are no x values. My x values really start at -4. And then we can assume that they just keep going this way for forever. And so that's just us just paying attention to what's going on with the x-axis. I don't care that this is going up and down right now. I just care about what's happening from left to right. So my x values start at -4 and they just continue out to that positive direction. So the domain would be from -4, -4 is included, out to infinity. Now, what about the range? Now we focus our gaze from bottom to top. I always like to start low and go high. So once again, we can assume that this graph is just going to continue in each direction forever. So that's just going as far down as possible and as far up as possible. So I just see that the y's go on forever in both directions. So my range in this case goes from -infinity to infinity. Okay. So let's look at another example now. And so for this function, just notice that I can draw all these vertical lines and they only intersect the graph once. So this graph is a function for sure. Okay, so now let's figure out what's the domain and range of this. Now in this case, when I think about the x values, and again, we can assume that the graph goes this direction for forever, so it would just keep going. So for the domain, notice that my x's start all the way out here, right? Out this way. So since they just continue on this way for forever, what is this direction? This direction is referring to the negative infinity direction. So my x values are really starting at negative infinity. Negative infinity gets a round bracket because it is not a number, it is a concept. And then just noticing what's happening from left to right, my x values keep going, keep going, keep going, keep going, boop, and then they stop. And so notice that once again this happens at -4, and -4 is included. So here is my domain. Okay, so now let's talk about the range. So now we're concerned about the up and down motion here. So notice that my range, I've got nothing here, nothing here, nothing here, and then I start here. What is this value? This value is -2. So you start with the lowest y value, and now where is this going? Well, I'm going to assume like this is going upwards, and I'm going to assume that this is just going to keep moving upwards. It might be moving upwards slowly, but I have no reason to see why it would like stop going upwards. There's no like asymptote or anything that I can see from this graph. So this graph is going to start here, and it's just going to keep going up for forever. So the range in this case then goes to positive infinity. And so that's how you can kind of play around with positive and negative infinity and domain and range. All right, so now I want to talk about how do you determine functions if this is all the information that you have. So what if all you're given is an equation? So I'll tell you, okay, honestly, the easiest way to know this is if you kind of have a sense of what the graph would look like. That gives you probably the best intuition. But what if you don't? What if you have no idea what the graph looks like? Well, then what you've got to think about is how does like this equation really behave? So remember, your inputs and outputs have this x-y relationship. This is your input, this is your output. So the thing that you're trying to figure out, right, is are you going to have this type of situation where one input could possibly go to two separate outputs? So as you're thinking about this, you're thinking about, oh, if I plug in any x, is it possible I could get more than one y? And no, right? So just as we're thinking about this, so as I continue to plug in a bunch of different x's, 0, 1, 2, 3, 4, I'm always going to get out my own y value. There's not like two possible y values, right? So this one is a function, and you're probably saying like, okay, I don't understand, like what's not a function? So actually, let me show you what's not a function. Very similar example, but I just tweaked it very slightly. So now I've got x equals y squared. This is different. The last one was y equals 3x squared. So now I've got the y squared. So when we think about input and output, we always assume that we're going in alphabetical order, and so the first letter is always our input, the second letter is always our output. So think about this. Now, this actually does kind of flip the script a little bit, because if I were to take, okay, so let's say that I have the pair -2 squared. What is that going to equal? That equals 4. So what is the input output here? This is the input 4, -2. Okay. And now, what if I have 2 squared? What does this equal? This also equals 4. And since I have this x equals y squared is my input-output relationship, so just notice what happens. This now is the pair 4, 2. And so look at what we've got now. We've got 4 going to -2 and to 2. So you've got to use your noggin a little bit. A lot of times, though, with functions, often it will be something kind of odd, and then you can probably prove it to yourself as to why it's not a function. Okay? So one more example here. So now I've got y equals 5 over x squared. So what do you think? So once again, we're thinking about this x-y relationship, input-output relationship. So you might be saying, oh, if I plug in 0 for x, this thing is undefined. That's actually fine. That has nothing to do with being a function or not. So the fact that you could get a 0 in the denominator, that has to do more with like domain and range. But as far as like any other x's that you could put in, if I put in any x, I'm going to get out one y. I'm not going to get like two possible y's in my input-output relationship. So this is still a function. It takes a little bit of practice. Like I said, I honestly think that the easiest way to understand this is if you know the graphs. It's much harder if you have no idea what the graph looks like. So if you're trying to like learn some of the graphs, you could try using graphing software just to help you kind of visualize what you're looking at. But otherwise, you can kind of just finagle with the points a little bit, try a couple test points, and remember, this is the input-output relationship that you're looking at. All right, so just a couple other things that I want to talk about here. So some equations, they might not actually look like a function, but you can actually manipulate them to look like a function. So let's say that I have 3x plus 2y equals 6. So this does not look like a function right now, but remember, we usually think of x and y as interchangeable. So, or sorry, f of x and y as interchangeable. So what happens if I solve for y? So if I were to solve for y, oops, and this was an x, negative 3x plus 6, and then I divide all parts by 2. I get y equals negative 3 over 2x plus 3. So negative 3 over 2x plus 3, so this is really just a line, right? This is an equation in mx plus b form. So a line is definitely a function, and so since I've written this now in terms of y, I can replace this with f of x. So if you've got a function and you've got it, you've solved it in terms of y, you can then replace that y with f of x as long as you know it's a function. Okay, so for the last example here that I want to talk about, I want to talk a little bit more about something I was talking about at the beginning of the video, in that functions are very handy because you know exactly what you want to do with them. So for this example, I have 3 different functions, and I'm being asked to calculate different values. So when I ask you to find f of 7, you know exactly what I'm asking you to do. I'm asking you to refer to the f of x function. And what a function means is where there was an x, replace that x with whatever I tell you to replace it with. And in this case, that would be a 7. So I can just plug 7 in, get 21 minus 5, and that equals 16. So that would be the value of that function. And the input-output, just to kind of mention that, would be 716 in this case. So what about g of 3? Well, maybe just pause the video here and you can try it and then hit play when you're ready. So in this case now, this is definitely referring to the g function, right? So I'm just going to replace the x's now with a 3. Oops, and this is 3 squared plus 4 times 3 minus 1. So that's 9 plus 12 minus 1. So that's going to be 20. And so this would be the pair 320 if I wanted to think of it like that. Okay, cool. So let's keep going. Let's do something a little bit more abstract. And this is actually something that you have to do as you move up in mathematics. So now I'm being asked to evaluate f of k. So don't overcomplicate this. The thing that you want to remember the most is, what is the deal with the function? Wherever I saw an x, replace it with whatever I tell you to replace it with, which in this case is a k. So that is what we have to do with a function. So I'm just going to replace the x with a k. And now in this case, is there anything else I can do to this? No, right? That's as far as it goes. That's all I can do. So if that happens, if you have to input a variable, there's no problem with that. You just do what it means to be a function. So with that in mind, I'm going to give you one that's a little tough now. G of x plus h. So again, don't let your brain try to add something more to this. So what you need to do is, where you see an x, now you need to replace it with x plus h. So this is going to have some interesting consequences. I would recommend that you pause the video here and you try to input this before I show you the answer, and then see if you know what to do. All right, so if I put in x plus h, this becomes x plus h squared plus 4 times x plus h minus 1. So notice now, in each place where there was an x, here and here, I've now replaced it with x plus h. And in this particular instance, we have an interesting consequence in that I now have to FOIL this out. So I've got to just run with it. So if I FOIL this out, I get x squared plus 2xh plus h squared, and then I can distribute that 4 plus 4x plus 4h minus 1. So, but believe it or not, being able to do an operation like this is actually pretty important when you start getting into calculus. So you might start seeing some strange calculations like this, and you're not quite sure why are we asking you to do that. It's because it is going somewhere. So just hold tight and get the extra practice. Okay, so one more here, just something that might look a little abstract. How would I evaluate h of 6? Okay, so h of x is this, and it was just a set of points, right? So if my input is 6, oh, there it is, 6 and negative 3. So in this case, I actually can just read it straight off of the set of points, and boom, there you go. Okay, so that's kind of your crash course review into how functions work, just kind of trying to remind you of everything. So that's it for this video, guys. I will talk to you in another one. Thanks for watching.